This section is 9.2 in the book. It is entitled Reflections. Reflections are a transformation, just like translations were in the last lesson. A reflection of an image simply makes a mirror image of the original over a line. That line is called the line of reflection. The line that you flip the object over is called the line of reflection. What basically happens is that you take every point on the pre-image, on the original, and it goes the same distance. It sits the same distance as it does from the line, but it sits in the reverse direction. The key points to remember in a reflection are if any point from the pre-image is already on the line of reflection, it stays on the line of reflection. The second key point is that the distance from the pre-image to the line is the same as the distance from the image to the line, just in the opposite direction. So what does that look like? An example that I have here is if I was going to reflect this triangle over this line. This is the line where x equals -3. If I were to reflect it over that line, I would take every point on this pre-image and I would measure how far away it is from the line, and then I would move it that same distance, only in the opposite direction. For example, this point on my pre-image is 1 unit to the left. So if I'm going to reflect it, I'm going to keep it 1 unit away from the line, but I'm going to go in the opposite direction. So if I was going left, I'm going to turn around and go 1 unit to the right. I would do the same thing with all the points to my pre-image. For the most part, just using the vertices or the corners of an object will get you the object shape that you need. I did this one. This becomes the prime of this one, like we learned in the last section. This point over here is 1, 2, 3 units to the left. So if I'm going to reflect it, I'm going to turn around and go 1, 2, 3 units to the right. Same here, 1, 2, 3 units to the left. I would turn around and go 1, 2, 3 units to the right. And now if I connect those 3 vertices, that would give me the reflection. This is my pre-image, now this is my image. They're still in isometry because they're still congruent. The figure did not change size or shape. It stayed congruent to the original. So it's an isometry. This is what a reflection would look like. Remembering in key point 2 that the distance has to stay the same. 1 unit away, 1 unit away. Okay. This one, I would do exactly the same thing. Remembering that if any of my points start on the line of reflection, they stay on the line of reflection. So this coordinate point here that's already on my line of reflection and this one are going to stay right there. They're 0 units from the line. They're going to stay 0 units from the line. So all I'm going to have to do is reflect this vertex and this vertex. You can count diagonally if you'd like. This one is a half unit diagonally down and to the left. So I'm going to turn around and go in the opposite direction. I'm going to go up and to the right a half unit. And then this one would be a half and a whole unit down and to the left. I'm going to turn around and go a half and a whole unit up and to the right. If I now connect those, just like the original image, pre-image, then this would be the reflection of this. This is the image, this was the pre-image. You don't have to do full shapes, you can do individual points. You do, however, have to remember how to graph those lines of reflection. Okay, for example, in this one, it says find the reflection of 3, -2. Okay, so we have to find the point 3, -2. 3 over, 2 down. And I'm going to reflect it over the line where x equals 4. Okay, anytime it says x equals, that means it's crossing the x-axis. So it's crossing the x-axis at 4. That makes it a vertical line. If I'm going to reflect it over that, I have to look and say, okay, where is my pre-image compared to my line? Well, it's 1 unit to the left. So if I'm going to reflect it, I have to turn around and go 1 unit to the right. So my reflection point, 3, -2, would become 5, -2. This would be my pre-image, this would be my image. A third type of problem that you might see is one where they give you the pre-image and the image and ask you to find the line of reflection. The easiest way to do that is just to look at your individual vertices and say, okay, where's the point that's directly in between my 2 vertices? So that, because it has to be, my line has to be equal distance from this vertex as it is from this vertex. Same thing, this one, and you could do that with any of your shapes. Okay, so if you took this point and this point, the distance in between them, distance in between them, distance in between them, and you will quickly start to see a line form. So if you draw in that line, that would be your line of reflection. If you have, if your question is on paper, you can simply fold your paper in half so that the one of these hearts would land directly on top of the other one, and wherever the crease is in the paper, that would be your line of reflection. Just like with translations, there are rules that you can follow for reflecting over the x-axis and the y-axis. There isn't individual rules for reflecting over, you know, x equals -5 or y equals -4. They don't have individual rules for those, but they do have rules for flipping over the x-axis and for flipping over the y-axis. These rules are written in rule notation. Here's what happens. You take your coordinate point, and when you reflect it over the x-axis, when you reflect it over the horizontal axis, the x value actually stays the same, but the y value changes to its opposite. What happens is, if this is your line of reflection, you look and say, well, it was 1, 2, 3, 4 units up, so you have to, from that line then, turn around and go in the opposite direction. So you'd have to go 4 units down. That's what gives the y its opposite value. Y is what tells you to move up and down. Same thing for reflection over the y-axis. The rule that follows is when you reflect over the y-axis, the y value actually stays exactly the same. What ends up happening is the x value goes to its opposite value. So if it was 1, 2, 3 units to the left, you would turn around and go 1, 2, 3 units to the right. Our last example would be to actually take that point, -3, 4, and where does it go? When you reflect it over the y-axis, where does this point go? Well, our rule is you take the opposite of your x value, and the y value stays the same. So 4 stays 4, but you take -3 and you make it its opposite value, so it would become +3, 4. You could count as well. If this is your line of reflection, it's 1, 2, 3 units to the left. You turn around and go 3 units to the right. And what do you know? You land on the point 3, 4. So you can do it graphically or you can do it using the rules. It's completely up to you. The second one, same thing. We're starting with that same point, but this time we're going to reflect it over the x-axis. The rule for reflecting over the x-axis is that x stays the same, but y changes to its opposite. So my x value would stay -3, my y value would go to its opposite, which would become -4. And if you look at that, if I'm reflecting over this line, I'm 1, 2, 3, 4 units above, so I would have to turn around and go 1, 2, 3, 4 units below, and look at the point I'm at, -3, -4. So again, you can graph it, or you can use the rules if you're doing reflections over the x or y axis. That concludes this lesson. Your homework is as follows.